What's up, guys? We're going to continue here with Chapter 6, where we're still working with systems of equations. Today we're going to be using a method called elimination. Make sure you jot this down. The elimination method is when you use addition or subtraction properties of equality to solve a system of equations. You don't need to copy this part down. I just want to show you why this works. Okay, so if 5 plus 1 equals 6 and 3 plus 4 equals 7, then the value of this side plus the value of this is going to equal this plus this. Now I know that sounds weird, but this is why it works, and maybe if we have a time when we get to one of these equations, I'll take a look at that for you. But this is where if I know that this added together is going to equal this value, and this added together is going to equal this value, if I add what's on the left on both equations, that should equal when I add what's on the right on both equations. All right, I'm not taking any numbers away from this or this or this or this. So when I add all these values up, it'll equal. So this is kind of why this works. If you have a little time, you could check that out with one of these problems just to see that it actually does make sense. It's probably weird looking to you now. No worries. All right. This is pitiful, but it's absolutely the truth. I walk around, you guys are doing your work, and this is what I see. 5 plus 3, just to be sure. Come on. Try to do these things in your mind and then believe in yourself. All right. Solving a system by adding equations. It says, what is the solution of the system? Use elimination. Elimination method, you're going to be shocked, is really, really simple. There's going to be 3 things that we're going to check. The first is, can I add straight down? So you're going to set this up just like when you first learn addition or subtraction. You're going to add straight down or subtract straight down or so on. You got to make sure that your like terms are lined up. So notice that I have x over x, y over y, and constant over constant. That's going to be very, very important. So if I add these values, in other words, I treat this like this is a column, this one's a column, and this one's a column. If I add these down, notice what happens. I have 2x plus 6x, which is 8x. I have 5y plus negative 5y, which is 0y. And then I have 17 plus negative 9 is 8. Well, what is 0 times y? That's going to be 0. So this really comes down to being 8x equals 8. Now, if I'm looking at these original equations, what I want you to notice here is that the y eliminated. That's why this is called elimination. The goal of using the elimination method is to eliminate one of the variables, which we did here. Now I have a single variable, so I could solve for that variable, and x would equal 1. To find the other value, I have to take that and substitute that back into one of these. So I'll have 2 times 1 plus 5y. Remember, when you're solving a system of equations, you're looking for the ordered pair that is on both of these lines. When is it true? So I go through and I solve this equation. And it looks like y is going to be equal to 3. So my ordered pair would be 1, 3. There's my answer. And again, you should plug these in, even if it's just doing mental math, to check and make sure that this works. So I have 1 times 2, and then 5 times 3. So that's 2 plus 15 equals 17. That works. Here I have 6 times 1 is 6, minus 5 times 3 is 15. Right, so 6 minus 15 is negative 9. That one works, so we know that it works for both of them. It has to be true. So the first thing you're going to check is if you add straight down, does it eliminate a variable? Here's one for you to try. The answer will be up in 3, 2, 1. All right, so here's what I got. Hopefully you got the same thing. If not, you need to go back and check your work. All right, so the first thing I told you was that you see if you could add down. So if I add down here, notice it doesn't eliminate any of these. So the second thing that you check, so we check adding, and if that's a no, then we go to subtracting. And here's how this works. I subtract straight down. And the way that I help myself remember that is if I put a negative in front of this right here, then what I'm doing is changing all the signs of these values. In other words, I'm distributing a -1 to every single one of these. So that's what I'm going to do here is I'm going to change the signs, and then I guess kind of adding down still. But before I do that, I have to go through and change these signs. So if I run a negative sign through there, first of all, I'm multiplying everything by exactly the same thing, a -1. It doesn't change the value. So I'm going to take this and make that negative, change that to positive, change that to positive. Now if I add straight down, notice what happens. I have 4x minus the x is 3x. Negative 7y and positive 7y is gone. And I have 3 plus 15, which is 18. It eliminated the y. This is subtracting down, where I have to go through and subtract all these values or just change the signs of everything. So here I divide by 3. And x equals 6. Substitute that back into one of the originals. It doesn't matter which one you use for this, but you do want to make sure that you are checking both of them. So we'll subtract 24. Divide by -7. I get y equals 3, so that my ordered pair is 6, 3. And we could check these real quick. So 24, 4 times 6 is 24, minus 21 is 3. That's great. Up here, be careful because I got some slashes in here, but that's going to be 6 minus 21. Okay, because 7 times 3 is 21. So 6 minus 21 is -15, and that one works. Here's one for you to try. The answer will be up in 3, 2, 1. All right, there's the answer I got. Hopefully you got the same thing. So let's continue here. All right, so if I'm looking at this one, it says, what is the solution of the system? Use elimination. So first thing we check is adding. So if I add straight down, does it eliminate? No and no. So I need to go to subtracting. If I subtract straight down, does it eliminate? No and no. So the next thing that I have to check is if I multiply something, will it eliminate? And that's going to be the third thing that you have to do. This right here is going to be related to adding these two values. If I tried to add 1/2 plus 1/4, 1/2 plus 1/4 I can't add because I don't have like terms. So I can or like denominators, but I can multiply this, both the top and the bottom, by 2. And I get 2/4, and I change this value. It's not the exact same concept, but it's very, very similar. So here I could add these things, and I get 3/4. That's what I'm going to be doing over here. So I'm going to first look at these values and think, well, which one is going to be the easiest for me to do that with? I see the 5 and the 15. That's probably going to be the one that I'm going to focus on. So here's what I mean. If I multiply this value by 3, I will get a 15, and all of a sudden I can use elimination. So I'm going to put parentheses around this. I'm going to put a 3 right here. I'm going to multiply everything inside this parentheses by 3. So I have 3 times 7, which is 21x. 3 times -5 is -15y. 3 times 17, I believe, is 51. Let me double check that. 51. Oops. And yeah, it is. Okay, so I wrote this one. This is here. And then I'm going to rewrite this one just so I have a little bit more space. So I have -2x plus 15y equals -32. Now you'll notice these are these same two equations. This one is this equation. It's just I multiplied everything by 3, and then this I just copied down. Now you'll notice if I add straight down, it eliminates this y variable. So we'll go ahead and do that. I have 19x equals, and then 51 minus 13 is 19. So x equals 1. And then I need to solve for the y, so I'm going to substitute that back in. I have -2 times 1 plus 15y equals -32. -2 plus 15y. Add 2. 15y equals -30. Divide by 15. And y equals -2. So I'm not going to go through the check on this for the sake of time, but 1 -2 is the solution to that. So that's using multiplication of one equation similar to when you're adding fractions so that you do get something that eliminates. Here's one for you to try. Go ahead and pause and give that a go. The answer will be up in 3, 2, 1. All right, here's the answer I got. Hopefully you got the same thing. I multiplied that first equation by 3. All right, let's take a look at this one. What if you have to multiply both equations? This would be the same thing as if I'm looking at adding 1/3 plus 1/4. If I wanted to do that problem, I'd have to change both denominators, right? I'd find the common denominator of 12, and I'd go from there. It's a very similar concept on this. I could focus on this one. I could focus on this one. It doesn't matter which one you do. I'm going to focus on this just because I'm dealing with smaller numbers. So I want to get these so that they have a common number. I'm going to go for 6. So I'm going to multiply this top one by 3. And I'm going to multiply the bottom one by, I'm going to put -2 because I want that to become a negative so that I could add straight down. So here we'll distribute this. I have 3 times 3x is 9x plus 6y equals 3. Make sure you're multiplying everything in there because that's one of the mistakes that I see students make a lot is they don't multiply all the values, especially as constant. It gets forgotten about a lot. All right, so here everything got multiplied by -2. Now if I add straight down, notice what happens. This leaves me with an x. This leaves me with 7, so x is equal to 7. I could substitute that back into one of the originals. And that's what I'll use to find my y. So I have 21 plus 2y equals 1. We get 2y equals -20. Divide by 2, and y equals -10. So you should go back and check. For the sake of time, I'm not. But the ordered pair that you get for this one is 7, -10. All right, so that's multiplying both equations to get something that will eliminate. You could have gone after the x. You could have multiplied this by 4 and this by 3, and it would have done the same thing. You'd still get the same answers for this. So let's take a look at one for you to try. The answer will be up in 3, 2, 1. All right, here are the answers I got. Hopefully you got the same thing. If not, go back and check. Got one more thing. So finding the number of solutions says what is the solution of the system, use elimination. So if I'm looking here, I would multiply this one by 2, right? And that would give me 2x, actually -2. So I want -2x minus 6y equals -18. Now notice here, I'm ignoring this one right here because it's right here. If I subtract down, what happens here? Well, this minus this is 0, and then this is 0, and then this is 0. So we end up with 0 equals 0. Anytime that happens, it means that they are the same line. All right, so we'd say all are infinite solutions, not all. Okay, and if you do that and you get two different numbers that don't equal each other, like you had 14 equals 37, then that would mean no solutions, which is similar to what we looked at in the last section. I got one more thing to look at here. The theater club sells 101 tickets to its first play. Student ticket costs $1, and adult ticket costs $2.50. Ticket sales are $164. All right, so we have students plus adults equals the total of 101. And then we know that an adult ticket's $2.50, so I have $2.50, and a student ticket is $1, so that's just S. The value of those two things is 164. We could use elimination here to solve this. Notice if I go straight down, if I subtract, I eliminate the S's. So here I'd have negative 1.5a, and here I would have negative 63. I could divide by 1.5. And I get 42. So the adult ticket sold was 42. In order to find the number of student tickets, I just take 101 and subtract it by 42. So 101 minus 42 is 59, or I'm substituting in here. So S plus 42 equals 101. And S equals 59. So that's how many student tickets were sold, and that's using elimination. A really, really simple way to do that. I believe that's all I have for today. Yep, that's it. So make sure you have taken good notes. I'll see you in class.